Okay, so section 2.1 is relations and functions. Have you guys heard the word function before in math? Sometimes you talk about in Algebra 1, not always though. Okay, so a relation. A relation is just a set of ordered pairs, so it's x comma y, so it's a point. And it's a pair of input and output values. X is the input, y is the output. So it's kind of like what you're putting into a t-table to get an output of the y value. Okay, the domain is the set of all possible inputs. The range is the set of all possible outputs. The y values. All right, so we have a table that shows the height and arm span of 12 members of the girls' basketball team. I didn't really do this. I didn't go survey. All right, so x is going to be my height, y is going to be my arm span. All right, and it says list the domain and the range. So the domain, this is really important. The domain is always all of the x values that you have. Your range is always all of the y values that you have. Okay, so you're going to hear domain and range a lot in Algebra 2. So a domain is going to be all the x values that I have. Now, some math teachers make you list it in order, so numerical order. I don't really care. So you can list them out. It's fine. Okay, so I'm going to have 178, 189, 158, 169, 195, and then I have 189 again. So see, I already had it once, so I'm not going to list it twice. So I'm just going to leave that one off, and then 193, 167, 164, and that's the end of the domain. So it's all of the x values that we have. I can't just list it and say it's 158 to 189. I can't do that because I don't have everything between there. So a lot of you guys so you can't say like that because I don't have like 159, 160. I don't have all those values. So you can't just list it like that. You actually have to list out the individual things. This is called roster notation. So some of you guys missed that on your test. It's just a list of items. Okay, range. Your range is going to be all of your y values. So all the y values, I have 180, but I have it twice, so I'm just going to list it once. I have 163, 169, 189, 182, 188, and 172. So that's the range, all the y values. So again, domain is all x's, range is all y's. All right, let's go to the next part. So a function. So a function is a type of relation. It's a specific type, okay? So this is really confusing for people, so see if you understand it. It says a function is a relation in which the first coordinate is never repeated. So in other words, for each x value that you have one and only one y value that goes with it. So it's kind of confusing. If you have a certain x value, so if I have like 2 and I got 4, if I have that x value listed again, you have to have 4. You can't have -4, right? It can only be the same point. You can only have that one point. All right, so one of my friends in grad school explained it to his class like this, and I kind of like it. So he talked about a soda machine, pop, Pepsi, Coke, whatever you call it, soda. All right, so imagine we have this pop machine. And you don't have to draw it because it's already here. Let's say I have 2 buttons that say Mountain Dew. I have one that says Pepsi. I have one that says Sprite. Or what's the Sierra Mist? Is that the Pepsi kind? Sierra Mist. Okay. You can have 2 buttons that say Mountain Dew, but when I hit this button, what should come out of the machine? Mountain Dew. When I hit this button, what should come out of the machine? Mountain Dew, right? If I hit Mountain Dew and out comes a Pepsi, right, something's wrong with the machine. It's not functioning properly, right? Does that make sense? So if you hit the same input, and for one of them you get a Mountain Dew, but you hit another one with the same input and instead you get Pepsi, that doesn't make any sense. It's not functioning, right? You were supposed to get that one specific thing that went with that one button. You were supposed to get Mountain Dew. But you could have multiple, you could have the same x value, you just always get the same y value out with it. Okay, so that is going to be a function. So it says if you have the same x values and get 2 or more y values, it's not a function. So, it says in each of the ordered pairs, the first coordinate represents the input and the second represents the output. So if you have 2 inputs that are the same, like a 2 and a 2, and I'm getting 2 different outputs, right? I'm pushing the button and I'm getting something different out. then it's wrong. And a lot of these math books will draw this complicated machine. I don't know why. They like draw this little thing. Like a conveyor belt comes in, your x value's going in, 2's going in, 4's going in, 3's going in. And for 2, let's say you're getting a 5 out. For 4, you're getting 6. For 3, you're getting 8. I don't know. You're getting these certain numbers out. But on the next one, if you put a 2 in and you don't get a 5 out, then it's not functioning correctly. So we'll draw like these complicated pictures. It's weird. All right, so anyway, so we're going to look at each point. So I have 0, 1, 1, 5, negative 1, 3, 2, 4, 2, negative 1, and negative 5, 3. Is this a function? No. Why? Yep, so you have 2, 4, and you have 2, negative 1, so it's not a function. You're pushing that button, the Mountain Dew button, so you're pushing a 2, and you're getting different things out. So the first time you got a 4, the second time you got a negative 1. All right, so how about the next piece? So I have 0, 0, 1, 0, negative 1, 0, 2, 0, negative 2, 0. Yeah, that one is a function. Does this make sense? You can push different buttons and get the same thing out. That's okay. You know, the Mountain Dew button, Mountain Dew number 1, you get a Mountain Dew out. Mountain Dew number 2, you get the same thing out. Right, so this is okay. So you're not ever having the same input, right? All of the inputs are different. So yes, it's a function. All inputs are different. All right, how about C? So 0, 0, 1, 1, 2, 2, 3, 3. Yeah, that one's obviously, yes. Okay. So it says state the domain and range of the relation. Is the relation a function? So we're going to go through and we're going to find each of these points. So see if you remember from Algebra 1 how to find the point. So you're going to count over. I count the grid lines or the spaces, I guess. So I count the spaces. So I'm going to have 1, 2, 3, 4, 5, 6. So this is negative 6, comma 0 is the first one. This one is 1, 2, 3, 4. 4, negative 4, 2. You guys see that? The next one is negative 1, 0. Negative 1, 0. The next one is 2, comma 4. And the last one is 6, comma 6. Okay, so your domain is all your x's. Your range is all the y's. So we're going to list them all out. And this time we'll do it in order. So my domain, so all my x values, well, I just have negative 6, I have negative 4, I have negative 1, I have 2, I have 6, right? So you're just finding all those x values. So your domain is negative 6, negative 4, negative 1, 2, and 6. And your range is all your y values. So again, I'll do it in order. You don't have to, but I'm going to have 0, I'm going to have 2, 4, and 6. Does that make sense? Okay, is it a function? Yes. So you never had like 2, 4, and then 2, 1 or anything like that, right? So you didn't have like the same x value but different y values. That's what we're looking for. All right, so we're going to learn what's called the vertical line test. Okay, so the vertical line test is going to determine if something's a function. Have you guys seen the vertical line test before? You're going to be seeing it. Okay. So if you graph something, and let's say I had 2, 4, and I had 2, negative 1, like that first example. So going back, remember how I had 2, 4, and I had 2, negative 1. All right, those 2 points, when you graph them, are lined up like that. Okay, they are on the same vertical line. So since they're on the same vertical line, it's not a function. You had the same input, but you got different outputs out. So it's like pushing Mountain Dew, getting Pepsi, pushing Mountain Dew, and getting Mountain Dew. See what I'm saying? Same input, different outputs. Okay, so that's bad. So that's not a function. So if you think about this, as you look at all these points, if I draw vertical lines through them, I'm only going through one point, right? I don't have 2 points on the same line. So it is a function then. All right, so let's do the next. All right, so it says determine whether each relation is a function. So types of fruits to their colors. Okay, so let's think about types of fruits to their colors. So let's say strawberry. A strawberry is red. And orange is orange. Lamag's least favorite fruit, banana, yellow. or brown. All right, so what's one that's making it not a function, Ezra?
Apple.
Ah, yes, apple. What colors are apples? Or, yeah, green. Or some in the last class we're saying yellow, right? So that's what's making it not a function. You have the same fruit, but it could have different colors. So your input has two different outputs. Okay, so because of that right there, it's not a function. So no, not a function.
What if it was strawberry and an apple then?
Yep. Because they're allowed to have different output or different inputs, but not, and they could have the same output. So think about what that means on a graph. So let's say I have 2, 4, and I have -2, 4. Right, and I had that parabola. You guys remember y equals x squared? That would be a function, right? Because it passes the vertical line test. Okay, so that's always how I had to think about it when I was in school. I had to think, does this make a vertical line? Is this okay? All right, so students in the class, their heights today. Okay, so how about, I don't know, who wants to share their height? Yeah, Jenny. Now, Mrs. Cox is also Jenny, and I'm also 5'9" as well. So does that work? Is that a function? It is a function because Jenny is different than Jenny, right? Jenny O'Keefe is different than Jenny Cox. Do you guys understand? All right, I'm not a student, too. All right, what else? Anybody else want to share theirs? Jada, how tall are you? Right? So each student is going to be different from every other student. Does this make sense? You will never have the same student. Like they could have the same name. Like in the last class, we had 2 Maddies, spelled the same way, M-A-D-D-I-E, but their last names were different. So what if I had said from the first name of students in the class to their heights today? Then this class would be okay. We don't have any repeats, do we? Do we? I don't know. Think about it. All right, but in the last grade class, then that would not be a function because we had 2 Maddies. Does this make sense? So you got to be kind of careful on these. So this is a function. So students are all different. All right, so like I said, the vertical line test is how I always determine if something is a function. So I think about it. I'm very visual. I like to think about the picture. So if you draw your vertical lines in, or if you run your pencil from left to right, that's kind of what I did. So I'm running my pencil vertically from left to right. You should only cross 1 point at a time. So see how each of these is only crossing like 1 point at a time. Okay, so this is a function. Okay, but B, do you guys see that's not a function? Yeah, if you even just look at the axis, there's 1, 2, 3 places where it's crossing. So this is a no. How about C? No. Right, because there's 2 places where it's crossing. So it can only cross 1 point in order for it to be a function. Okay. So how about this one? So think about it graphically. Think about the picture. Okay, if you graphed all of it out, you'd have -2, 4. But then it says you also have 2, 4. So is that allowed? Yeah, it's a function. Yes, this works. But what if I had like the 3 and it not only went to 9, but it also went to 16? Then it wouldn't be a function, right? Does this make sense? All right, how about the last one? Function?
No.
No, because the 1, 3 and the 1, 8. So not a function. All right, so it says relations and functions can be represented by equations. Okay, and then these equations can be graphed. Okay, so we're going to graph. Now, I know it's been a long time since you guys have graphed things. So when we start out with our graphing, we're going to use a t-table. Okay, so it says graph the equation represented by y equals 3x minus 1. So I'm going to have x, and my y value is going to be 3x minus 1. So I'm going to pick x values, and I'm going to input them in to get the output. All right, and usually when you want to pick like positive numbers and negative numbers. Okay, so I'm going to pick -2, -1, 0, 1, and 2. And that's pretty standard, but it doesn't have to be. Like you could pick whatever you want. Okay. Okay, so on the first one, let's start down at the bottom. So let's plug in 2. 2 is really easy to plug in. 3 times 2 is 6, minus 1 is 5. How about 1? What do you get when you plug in 1? 2. What do you get when you plug in 0? So -1 when I plug that in, -3 minus 1, -4. -6 minus 1, -7. All right, these are all points. So I have -2 comma -7, -1 comma -4, and so on. So -2 comma -7. 1, 2, 3, 4, 5, 6, 7. -1. Oh, whoops, I went the wrong way, didn't I? Could have gotten a bonus point. -2, 1, 2, 3, 4, 5, 6, 7. -1, 4. 0, -1. 1, 2. 2, 5. Try to draw a nice straight line. Oh man, I failed. Need a straight edge. All right, so I have my straight line. That's what it is. It's a line. You could have picked any value for x. You could pick 1.5 and you'd get a point out as well. So it doesn't have to be those particular points. Okay, so let's talk about the domain and the range. The domain is all the x values that are on a graph. Can you guys get your heads up, please? All right, so all x values on the graph. Okay, I could have picked whatever I wanted to. Does it make sense? I could pick 5 million. I get 15 million minus 1, so 14,999,999. All right, that's all on the graph. Does this make sense? You can pick whatever you want. All right, so your domain is all the x values that you have. So this is kind of confusing. I'm going to walk to the front. All right, so what I do is I take my hand and I move it from left to right, and I see if I have all the x values. So as I go across, you have a point that's matching up down here. So as I move across, you get every single x value. Even when you're over here, yeah, there's a point over there. So my domain is -∞ to infinity. So your range is from the bottom to the top. You want to see all the y values you have. You have a point down here, that's matching them somewhere. You have all the points -∞ to infinity. So for a line, your domain and range is -∞ to infinity. Both of them. You have all real numbers. Yep, you could write the fancy R. So -∞ to infinity. Was that Connor? Or the fancy R, right? All real numbers. All right, is this a function? Does it pass the vertical line test? Yes. All right, so that's a pretty easy one to graph. If you guys remember way back to Algebra 1, this is what we're going to be doing later in the chapter. But this is in the form y equals mx plus b. M is 3, and that represents the slope. B is -1. So if you check, your y-intercept is -1. You could graph that first. And see how you go up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Do you guys remember how to graph that? Okay. All right, next up. So it says graph the equation represented by x equals y squared plus 1. All right, and this is a little bit harder. So I gave you a hint, and I said it's easiest if you choose y values. Do you guys see why it's real easy if you pick a y value? You're just squaring it and adding 1, squaring it and adding 1. All right, so let's pick like -2, -1, 0, 1, and 2, like we did before. All right, so I'm going to do this quickly. So if I have 2 squared plus 1, 2 squared plus 1 is going to be 5. 1 squared plus 1 is 1 plus 1, so 2. 0 squared plus 1 is 1. And then we get to the negatives. This is what I was talking about in the beginning of class. The whole y value is being squared. So -2 squared plus 1 is giving you 4 plus 1, so 5. And -1 squared plus 1 is giving you 1 plus 1, so 2. Okay, so I have 5, -2. I have 2, -1. I have 1, 0, 2, 1, 5, 2. Okay, and you could pick any values. You could have picked like 2.5 for your x to put in, or you could have picked, I guess, a y equals -1.5, and you would get everything kind of in between there. Do you guys remember what shape this is called? Parabola. Parabola. Right? Parabola, not parabola. All right, so parabola. Find the domain and range. So this is a little bit harder. So do that trick that I just talked about. If you move from the left to the right, what's the first x value you hit? So as I'm moving my pencil left to right, don't draw these lines. I'm just kind of doing it so you can see what's the first x value you hit? 1. So your domain is going to start at 1. And I'm going to have bracket 1 because it includes that 1. What's the last y value you hit? It goes on forever, right? So infinity. Okay, how about range? So if you're moving your pencil from the bottom to the top, are you always intersecting a point? Yeah, this is getting bigger and bigger and bigger. So way down there on the right, you're going to be intersecting those lines. Okay, so this is going to be negative infinity to infinity. And that one kind of makes sense because you could have put anything in for y, right? There was nothing that you couldn't put in. All right, so is this a function? Yeah. No? I heard no. Is it? It's not a function. Why? It doesn't pass the vertical line test, so no. All right, so let's move on to function notation. All right, so when you see function notation, it's a little bit confusing when you first learn it. So it says f of x equals 2x plus 5. F of x is the y value. So that is the y value. Okay, x is the x value, obviously. All right, so if you have g of x equals 3x minus 2, it says evaluate each function value. So it's saying find g of 0. So what that's representing is find y that goes with x equals 0. So you guys done these before? Some of you, I hear you saying how to do it. How do you do it? I heard plug in. What do you do? I thought I heard you say it. All right, so what it's saying is plug in 0 wherever you have an x. Okay, see how it's like g of 0? We don't say that g times 0. It's g of 0. It's saying in the g function, replace the x with that 0. Okay, so you're going to have 3 times 0 minus 2. So g of 0 is going to be negative 2. Okay, that represents the point 0, negative 2. You plugged in 0 for x, you got negative 2 for the y value. All right, so let's try this next one. So g of negative 2.8. So I have 3 times negative 2.8 minus 2. So 3 times negative 2.8, is that negative 8.4? Is that what that is? Check it for me. All right, minus 2. So you get negative 10.4. All right, so what we have is g of negative 2.8 equals negative 10.4. This represents the point, right, it's a point, negative 2.8 comma negative 10.4. Because it's saying plug in negative 2.8 for x, you get a number out. So you have an input, you have an output. Does this make sense? All right, g of 1/2. G of 1/2 is 3 times 1/2 minus 2. So it's 3 over 2 minus 2. So 3 over 2 minus 4 over 2, if you get common denominators. So it's negative 1/2. So g of 1/2 is negative 1/2. So again, that's representing a point 1/2 comma negative 1/2. Okay, the next one, f of 0. Okay, now it's telling me to use the f function. It's using that letter f, so I'm looking at the f function. So f of 0 is the square root of 0 squared plus 1, or plus 5. So 0 squared is 0 plus 5, so it's the square root of 5. So f of 0 equals the square root of 5. Again, that's representing a point, 0 comma square root of 5. You guys see what I'm saying? It's really not bad. It's never multiplied. Like, you never get 0 on the left side. It's not saying f times 0. It's saying f evaluated at 0 if you input 0 into the function. All right, f of 2. So f of 2 is going to be 2 squared plus 5, which is square root of 9, which is 3. So f of 2 is equal to 3. F of negative 2. So remember, if I have a negative, I go ahead and put it in parentheses. So when I see it squared, the negative's being squared as well. So you get 4 plus 5. So you again get square root of 9, which is 3. So f of negative 2 is also 3. Still a function, though, right? That can happen. All right, so on your test, I like to make this really tricky. Okay, and I like to give you multiple functions. So whenever I say things like on the test, you're like, oh, she said on the test, right? So I say, oh, f of x is 2x minus 1, and g of x is x squared plus 3. And then I ask you things like f of 2 plus g of 5. All right, f of 2 is saying look at the f function and plug in 2. Right? So f of 2, what is f of 2? Can you do it in your head? 3. Right? You're plugging 2 in for x, so you get 3. G of 5 means look at the g function and plug in 5. 5 squared plus 3 is 25 plus 3, so 28. So then 3 plus 28 is 31. So I ask things like that a lot. Okay, next page. So it says use the graph of h on the right to evaluate h of negative 3, h of 0, h of 4, and h of 6. All right, so what is this saying? When you see h of negative 3, it's saying that's the y value, right? For an x value of negative 3. So it's saying find y value that goes with x equals negative 3. So we go over. Let me say, okay, 1, 2, 3 to negative 3. What is the y value of the point on that graph? So if I talked about the point, it's negative 3 comma what? 4. So that means h of negative 3 is 4. Does that make sense? Okay, you guys try the other one. So find h of 0, h of 4, h of 5. Or h of 6, I guess. I'm going to pass these around too. This is your homework, and then there's challenge prompts too. So if you want an extra challenge, all right, so if you look at h of 0, so that's saying an x value is 0. What's the y value of that point on the graph? It's also 0. So it's not saying h times 0, it's saying the x value of your graph is 0. What do you get? H of 4, what do you guys get for that? 6, so it's up there. That's 4 comma 6. So it's 6 goes with it. And h of 6, what did you get there? 3. Did everybody get those values? Good. All right, so in the last example, so it says let a function be defined by the following. So the independent variable is the student's number on the class roster. So I'll give you your number. And the dependent variable is defined by the student's birth month plus birthday. So my birthday is January 2nd. So my birth month is 1, my birthday is 2. So 1 plus 2 is 3. That's going to be the number associated with me. Does that make sense? Okay, so let's say, oh, who's first on my roster? Let's go with Dakota Allen, first on the roster. So Dakota, his independent variable is 1. He's first on the roster. What's your birthday? December 7th? Pearl Harbor, right? 12/7. So what's his number? 19. Does this make sense? All right, so let's go with 1, 2, 3, 4, 5, 6. Dimitri, you're number 6 on the student roster. All right, what's your birthday? March 15th. Is that the Ides of March? Man, you guys have fancy birthdays. Look at you. All right, so March 15th, so that's going to be 18. Anybody else want to go? Yeah, Evan, you are, oh gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. You're 21 on the roster. Okay, when's your birthday? July 7th. Is there anything fun with your birthday? I don't think there's anything fun. I'm trying to think. So 14, not fun. Pearl Harbor wasn't fun. Ides of March isn't really fun either. All right. Let's see, who else? All right, so we got, where are we? 2. Yeah, Tyler Arnold, that's right. So Tyler, number 2. So when's your birthday?
May 8th.
May 8th. Okay, so we got 13. All right, let's see, who else do we want? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Robbie. 22nd? 27th. Oh man, you got one of those right after Christmas birthdays. That's me too. All right, so 39. I also have a twin, so I got there right after Christmas, and then I had a twin for the birthday too, so it was like we didn't get any birthday presents. All right, so let's see. Who else? Let's go with Jacob Benson, because he's number 3 and I can count. Jacob, when's your birthday? March 9th. Okay, so you get 12. Does anybody have any of the same numbers as these people? So you could have the same number, right? There could be someone who has a 12 as their number as well. They could be like 4 and 8, right? That would work. Okay, is it always a function? Why is it always a function? Class numbers are all different, right? So class number is always different. All right, so I passed out your homework, or you should have been passing it around. All right, so that's going to be due, I think, Tuesday next week. I have it on that line, but I believe it's Tuesday next week. And then the next time I see you, Wednesday. All right. All right, see you guys later. Yep. When